Hey, what's going on, folks? It's Mike here, and welcome to the D programming language series. In today's lesson, we're going to be talking about structs in the D programming language. So we're going to do just a little bit of an introduction here. If you've seen structs in other languages, you'll find there's some similarities. But basically, structs are a way that allows us to create our own user-defined type by aggregating other types that exist or have otherwise been created or imported in a library. So with that said, let's go ahead and look at structs from the D language reference, and then we'll go ahead and code up some examples ourselves. And I'll show you something really cool at the end that you can do using D's introspection capabilities. So make sure you stick around for that. All right, so with that said, let's go ahead and go to the language reference here. We're going to go down to structs and unions. Unions are a related idea. We'll get to that in the series. Make sure you subscribe so you don't miss it. But let's just go ahead and look at structs for now. So if you've programmed in other languages, Java, C++, you've probably seen classes, or even in those languages, you've probably seen in C++ structs and their familiar ideas. But as defined here, structs are simple aggregations of data and their associated operations on that data. So it's a way for us to collect information together. Okay, so let's go ahead and look down a little bit more here, and we can see an example struct here. This is the name of the new data type. Struct is our keyword, and wrapped in the curly braces is how we're grouping everything together. So again, this value I here is just sort of part of the struct or an offset into some data here, saying that we have some integer here. Now let's go ahead and just play around with this structure here, or this idea. We'll get to some of the other contents here and some of the cool things you can do with the D language. But again, let's just look at how we can think about structs here in our language. So what I'm going to go ahead and do here in our example is create a new structure here. So something like a student, for example. And again, we don't have a student as a primitive type here, but we can again aggregate different fields together, like maybe the student's identification number, or maybe attributes about them, like their age, date of birth, whatever information that you want to keep track of here, and pack these related ideas together in one type here. So that's the idea. So let's just go ahead and draw out this structure here as we create this new type. And what we're doing is we've created a new student, and we've got in D 4 bytes of information for the ID, and then 4 bytes of information for the age, because the type is integer. But we've again packed these pieces of data together, and again we can just conveniently work with one student at a time. So let's go ahead and look at creating a new student here, student S, and let's actually give them a better name. Let's name them Mike. Mike's ID will be equal to 1, 2, 3, 4. And Mike's age will be equal to 99 here. I'm an old timer. So let's go ahead and run this code here, just to show that it compiles, and it compiles and runs fine. But what you can see here is the syntax here, when I use the dot, is to access a specific field. Now what that's doing behind the compiler, behind the scenes here, is that's telling us to offset and access ID here, wherever I have Mike.id, offset 4 bytes and set that value to 1, 2, 3, 4. Or if I have Mike.age, offset 4 bytes here, plus another 4 bytes to get to the age, which I set to 99 for that one instance of this student here. So again, just to give a little bit of the terminology here, let's go ahead and rewind. So student is the name of our new data type. And sometimes we call this a user-defined data type, or type for short. Sometimes you'll see this UDT here. And we've got fields here in our structure. Fields, for example, ID and age. And sometimes I'll call these member fields, because they're members that are within the scope of student. I can't access ID, for instance, out here. It's not a meaningful variable here. Okay, it's not something that I'm declaring or anything of that notice here. And then when I create the student here, so Mike is an instance of a student. Okay, so again, student is the new type that I've declared, and Mike is an instance. Okay, or we call this Mike is a new object. Okay, in the D programming language, just like in Java or other similar languages, we create an instance of this particular type. And that'll be the same terminology that we use when we talk about classes. Okay, So let's actually make use of this information here. Let's go ahead and just write out these values. Mike's ID. I'll put a comma here and a space, and then Mike's age. And let's just go ahead and write that out here just so you can see these fields here. Now, just like we've learned other things and concepts in the D programming language, like arrays, for instance, I can create an array of, say, 10 students, and just call these my students here. And then I could iterate through each of these students here. So I could say for each of my students, S in students here, and let's just go ahead and write out each of these students here. And we're just going to replace this with s.id and s.age. Okay, so let's go ahead and give this a run here. Now, I did a little mistake here, misspelling students. Let's make sure we fix that up here. And then it's going to run here. So I'm going to go ahead and expand this here. And again, show what happened here. So this is an array of students. And again, I've just instantiated 10 of them. Now, of course, in D, whenever we initialize a variable, we get a default type here. So the ID and age is just going to be whatever the initial value is for ID. Okay, so again, this has default, or the .init value of an int is 0. Okay, so that's why we're seeing zeros just printed out here. But otherwise, I could access each of these values here and assign them accordingly if I wanted. And of course, as we remembered, if I was going to reassign those, I would want to make this a reference here as usual here. Okay, so we can have arrays of students. We can use or create dictionaries. We can make these the unique keys. We get all these abilities here. And again, the advantage of if I have an aggregate type here, one power that I get here is, let's say I have a function here called create student, for instance. I can actually return an instance of a student here. And I can sort of say, you know, what's their age, what's their ID. I can create the student here, S, and then assign them these values here, and then return S here. And I'll go ahead and run this just so it shows that it compiles, but the power here of this is, well, when I'm returning a student, it's like I'm able to return two values. So that's one of the use cases of a structs when you want to aggregate or pack together things. Now, we'll see in the D language there are other mechanisms for doing this, like tuples, for instance, that you could use for returning multiple values. But again, it's just one of the tools that you can use outside of having to use, you know, return parameters or the normal limitations of a function just allowing us to return one value. All right, so that's just something we can keep in mind. Now, we'll get to the actual construction of student in a little bit here. So I'm actually going to remove this example, but just wanted to show you, or I'll leave it in here, example of using a struct to return two integers effectively, because that's what a student is here. But what I really want to show you is part of the advantage of using structs here is that I can also have functions associated with student here. So I can have member functions here, for instance. And let's just go ahead and create something that does a return here. And this will just be called print here to print out the student values. And then I can just write out the ID. And I'll go ahead and put ID here and a space. And then let's go ahead and put the age. And I'll go ahead and write out the age here. Okay. So now instead of writing this line here, where I was writing out Mike here, what I can do is just actually call a member function here, print here, and that will write out my age and the ID here. Okay, so it's calling this member function here, and this is looking at the specific instance of Mike here to see what the ID is and the age. Okay, so that's the idea. Now in Dlang, and again, I'll show this later, we can show how to share these values. But again, it's important that how this is defined here, that each instance, every time I create a student, I get one that has its own unique ID and its own unique age. Okay, so that's the idea there. Okay, so again, this is just to show, and let's go ahead and label this Mike over here. And if I create some other student, it gets its own memory here, its type student, and it would get 4 bytes for its own ID, whatever we set it to, and 4 bytes to store whatever age that we set it to. Okay, or like in our array where we stored the different students here. Again, these each have their own memory location. All right, so that's the basics of a struct here. And there's actually more that we can do with structs, but I want to save that for a little lesson. But I do want to give you a little bit of a bonus here just to show some cool things that you can do in the D programming language. So for instance, and I've mentioned this word before in this series, we have what are known as introspection capabilities here, if I can spell it right. Introspection. Let's see if I can get it right. There we are. So we can actually see or investigate what a struct is. So let me just go ahead and show a little tiny example of this. And again, this will be something that's new if you're coming from a language like C, for instance. What I'm going to do is index and just actually look at this struct here. So the different parts, or I'm going to call these the members, member, or even a better name for this is the fields here. And then I can actually look at the struct here. So let's look at a particular instance here, Mike, and I'll say it's tuple of. Okay. Now, what is tuple of here, and what exactly am I doing? Well, let's go ahead and look at our properties here from the help page here. Let's go to properties, and you'll actually find that for each struct instance, I have this .tuple of property. Now, I have some of the things like the size, for instance. So if I have 2 fields, an age and an ID, right? We've seen that that is in this drawing here, 8 bytes that I get back here. But if I look at the specific instance tuple of, that'll actually give me all the struct fields. Okay, so let's just go ahead and see how we can do this. This is sort of a for fun thing here to, again, show you why D is an awesome language. But what I'm going to actually do here is write out here, using something known as traits in the D programming language, all of the identifiers from this particular instance here. So this will be Mike, tuple of, and then the index into these fields here, which is one way to do this. I'll just do I here. And what's really neat, if I run this, and let's see if I made a mistake. Again, just trouble with the spelling today. Identifier. There we are. Highlights, much better. But it's kind of neat because I can actually see that ID and age is here. So you can actually, as you sort of programmatically run through this, if you're trying to assign stuff, or maybe if you're dynamically creating these structs, which is a big part of something that we're going to talk about later in this series, so again, make sure you subscribe, and want to create these structs by using mix-ins or some of the more advanced features of D, you can actually introspect and see what the different fields are, which you can't always do in other languages. So I just wanted to leave that with you here for now. All right, folks, so with that said, we've looked at structs, this basic idea that we can create a type. We can have member functions that are associated with each individual piece of data for each instance. So for instance here, where I'm printing off Mike's particular data, which has it set here, this member function will work on the specific ID and age for Mike. We can use this with arrays, dictionaries, any other types here, and I've left you with a little bit of a teaser here for some of the cool introspection capabilities that we have in the D language. So with that said, folks, thanks for joining and learning about structs. I've been putting them off for a while, but we're going to need them as we get into some cooler things in the D programming language. Now, I've got to talk about a lot of other things like how to construct a struct, and constructors and destructors and copy constructors, struct literals, all sorts of other interesting things. There's some other big distinguishments that we have to think about in D when it comes to structs, like value versus reference types, which we talked a little bit about. And we're going to cover those in the next video, so make sure that you stay tuned for that. And as always, folks, thank you for your time and attention. And as always, I will have this video in the courses on my webpage here if you want to follow along and track your progress. Again, there's going to be a few lessons on structs, so it might be a good idea just so you can make sure you keep track of where you are as you're following along with these examples. All right, folks, thank you as always for your time and attention, and I'll see you in the next one.